Alright, AP student, this is Mr. Chang. So I'm looking at your work. I find a few things that can really help you in your test. Number one, total area. So when you find the total area of a region, you don't just take the integral because the integral is not the total area. The integral is the net area. What's the difference? The integral will take the area above, subtract the area below. When you find the total area, which means you want just the positive area. So anything above should minus the area below. That's one thing. Like you think about the thing above the graph and below. If I ask you if this is 4 and 3, the total area should be 7, but the net area the net area will be just 1, or the integral will just give you 1. So in order to find 7 for total area, you're supposed to find this point and then you do the integral this way and you subtract the integral this way. Okay, so the integral give you the number of the area of under the graph, you need to consider as signs. For one of the question that consider this, you actually need to see where they cross. Okay, you need to solve where they cross. So you need to picture the graph. The graph goes something like that, and then the other one go this way. And then you want to find they also give you two lines from 1 to 3. So actually there's two area in which one of the part from 1 to 2, one of the function, this straight line is above the other graph. So you minus, right, let's say this is a f of x, minus f of x, and then you do dx. However, for the second part, is the f of x is bigger. So f of x minus g of x dx. And then you take the integral from 2 to 3. Okay, so you need to picture it and then consider which part to take the integral. So it's not that easy, just subtract them and find. You need to picture, visualize the graph. Okay, another question I want to try is, all right, another question is if you are given this function, how does it look like? Okay, this is the function look like this. If x is positive, the absolute doesn't do anything. X over x is just 1. When x is positive, is 1. When x is negative, the top become positive, but the bottom remain negative. So the over become -1. So the graph looks like this. And then at 0, the function equal to 0. So it's this. This is the graph. The question asks you what's the value of the integral from -5 to 3. So -5 here to 3, the area here will be 5, the area here will be 3, right? Because it's 1 times 3. So the integral, not the total area will be 8, the integral will be -2. That will be the answer. Okay, so again, integral will have sign specific, positive, negative, but then area, they just want the net area, the not the sign, but the area. So you need to read the question carefully. Now, for question, one of the question is about the u substitution. They give you something like this. Okay, they have an integral in terms of x, and then what are the bound here? We actually didn't do this kind of question in the test. The bound is about the x value, right? You want to take the integral for x from x when x equal to 2 to 3. So when you do a u substitution, you don't want to have the x value for the bound and then everything else is u. You want to change all of them. So they give you u is 2x minus 1. You can see the substitution here. Well, but then how about the dx? You cannot just leave it like g of u dx. First, it's not one of the choice. And also, when you do the substitution, you want everything in the same variable. So everything should turn into u. So how can you do it? You take the derivative here, right? You take the derivative, so you realize actually du is 2 dx. So this dx can be replaced if you stick a 2 there. So if I stick a 2 there, then I need to put a half. So the 2 dx will replace a du. Or you can just move the 2 to this side. Okay, so dx is half du. See, like half du. Now finally, that's not enough. So is the answer just half g of u du? There's one of the choice. There's one of the choice there. It's not, because those are the bound for x, not u. So if you turn everything into u, so what does it equal to? When x equal, look at this equation here. When x equal to 2, actually u is equal to 3. When x is equal to 3, like 2 and 3 here, x is equal, u is equal to 5. So therefore, this whole thing will turn into 3 to 5. So that will be the answer for such a question. Okay? There's a question on finding the area under such a thing. Okay, it's also, I saw that you have the answer. You only mix up the positive and negative. So from 2 to 12, all right, would the answer be negative or positive at the end? It would be negative because the whole thing is under the curve. So you find the whole area. The area will be 6 by 10. So the whole area is negative 60 under, and then you plus the area here. Then you're left with that. Okay, so that will be the integral. Okay, so you just mix up the sign. And there's a question about continuity. So they give you a function defined as a two pieces. And then it says if it's continuous, what is the value for C? The two pieces separate at 1, all right? So to be continuous, which means there's no jump. So at the end points, for each pieces, they should be the same. It can have a sharp turn. It may not be differentiable at 1, but it's on continuous at 1. So therefore, when x equal to 1, where the two pieces separated, when x equal to 1, okay, the two values should equal. So you just let it like this. So you just solve this equation, you can find out what's the value for C. All right. All right. There's a question about the inverse sine function. Um, they may have one question like this, so I think it doesn't worth remembering the inverse function. You could, it give you one point, just find what's the derivative of the inverse function, try to memorize them, sine, cosine, tangent, just 3 of them. But then they may not have such a question, so I don't worry too much about that. Like, this is one point that we may not need. You know that you just need 66 to 67% for the whole test in order to get a 5. Okay, so it's not designed that you can get every question. Okay, so there's a question about, they give you a point, okay, they give you a derivative, and then they ask you what's the second derivative. Okay, so notice that this is not x. So when you derive y with respect to x, is 3y squared. Don't forget chain rule. You're deriving it implicitly. Okay, and then plus 3 becomes 0. So the second derivative, this is given. They ask you for this. So now you take the derivative of this, and then you get this. Don't forget this part. And then how are you supposed to do this part? Well, dy dx is just equal to that. So you just plug it in. So you just plug it in. You just plug this whole thing in. And then what? They say when x is equal to 1. Well, how do you use this value? Well, here, there's no x. Sometimes they have an x here. Well, then you plug in the x. But there's no x. Well, but you only have y. What's the value of y when x is 1? Well, it's given here. When x is 1, y is equal to 2. So this whole thing, you just plug a 2 there. And then that will be your answer. Right? You just plug it in. That will be the answer for this question. The next one is finding the particular solution to the differential equation. This is a derivative, so it's a differential equation. Asks you to find a solution, which means to solve it. So to solve it, you integrate it. If something on this side is something you've seen on the formula sheet, you can just integrate it right away. Otherwise, we only learn one way. Like we do the substitution too, the u substitution, but this involves a y here. When there's a mix of x and y, the only method we learn is separation of variable, right? So put the y on one side, put the x on one side, all right? We only learn this way. And now you integrate it, and what does that become? Right, when you take the integration, what does that become? Become x and then plus c. So now to solve for y, which means you just multiply everything by 2 to get rid of that. So multiply everything by 2. The c multiplied by 2 is still c. Okay, well, you can also plug in the number. You can use this information, plug it in. When x is 0, all right, y is negative 2. So therefore, c is equal to 4. Okay, so you jump to this equation. Did you see what's happening? You can plug this information here or there, doesn't matter, anytime. Then you find out c is equal to 4. So this is your final form. So therefore, you square y is equal to the square root of that. In the answer key, they have a plus answer and they have a minus answer. You want to see which one work. If it's the plus answer, you actually see that this doesn't work, because in that case, y is always positive. When you plug a 0 here, you have a 2. If it's positive, then y should be equal to positive 2. But then it's negative. So when you square root it, you have a plus or minus. Like by default, most people will take the plus. But in this case, because of the initial condition, you take the minus. Okay, so that's the only error you make, I find, for some of you. All right. All right, the next question is they give you a diagram, you have an x square, like they cross here. Where did they cross? The point they cross is 4, 2, I think, something like that. Yeah, 4, 2. Okay, they ask you when they revolve this thing around it, what did you get? You cannot just do it in one equation. Like you can't take the top equation and then subtract the bottom equation and then just, right, that will be the radius, and then you say, oh, pi r square, and then from 0 to 4, that's the answer. Okay, well, that's one of the choices. You can't do that. Do you know why? Okay, because that will give you, because if you do pi x minus this, in here it will be this area. But no, we only want this area, not the whole thing. You need to do it in two separate integral. In the first part, you only have x, root x, and then the bottom ceiling is not x minus 2, it's just 0. So you will do root x, that's your radius, pi r square from 0 to 2, not 0 to 4, plus you would take the integration of this, which refer to this part. Okay, this minus that will give you the radius here. Oh, it's the big circle minus a small circle too. So it should be pi r square minus this square, and then from 2 to 4 dx. And then you actually need to like do some simplification and like try to figure out which one is equivalent and all that, because like this part and that part may be the same. And so you need to know the concept and also like do the math. Is very heavy in algebra. Okay, so next question. You're given a tangent, something like that. Okay, do you know what does this equal? Like what does it apply to? The limit? You need to use L'Hospital rule, because if you plug in a 3, tangent of 0 is 0. And then I guess if you plug in 3 here, E0 is 1. 3 minus 3 is 0. Okay, that's the case for L'Hospital rule. So you take the derivative of the top, secant square. All right, and then you take the derivative of the bottom. So the derivative is this, the same thing, minus 1. And then you plug the number in and so on, and then you will get the answer. Because if you plug a 3 in, the bottom now will become 3 minus 1 is become 2. And then you plug a secant 0, okay? And then that will be undefined, I think. So something like that, the answer, or like you plug it in to see what does that equal to. Secant is 1 over cosine, so it's equal to -1, and then square is equal to 1. So the answer is 1 over 2. Okay, so this is what you're supposed to do. And there's one question on mean value theorem. You need to know what it is. It is the slope. Like, do you remember that? The slope equal to a point there. Okay, so you find out the slope here, which is 8 over 8. So the slope is 1. You solve this equal to 1, find the x value, that's your answer. All right, so you need to know what the mean value theorem is, which they always ask such a question. Okay, so this is the first video I'll make you. I'll try to see if I can make other video. Well, actually, that's pretty much the end. So I think that's the end. This is the video. I hope this is really useful for you. Okay, thank you, everyone. Bye bye.